replacing that old hot water heater, which is domestic water only, with a new one, which is a Combi. We are draining the house of water at the moment, and the pipes go up this way, they go up this way, and then they come back around. They go into the pipe here, and then we cycle through down below. Let's just take a few pictures of these. So this one has just water inlet, hot water out. It's got gas hookup. It's got all the other relief valves and whatnot. It also has ventilation in and out. So we're going to do our best to cut off this pipe. And then once we're done cutting off that pipe, we're going to circle it back around so that we can use the electric water heater for the time being while we spend our time replacing this. So first step is draining the house. All right, we are through phase one. So phase one, we wanted to put in a loop back valve here. So it literally just loops back. So water comes up here, loops into here, goes back. That's just for maintenance. And this is hooked to the electric water heater, which is our backup emergency water heater for situations just like this. And now we're gonna go from here, gonna go into the replacement unit. This is what we're pulling out. So we disconnected the pipes underneath, the gas, which is right there, the hot water, which is right there, our intake, and hot water out. And now we're disconnecting the vents. So we are just going to cut that vent right there, just to get this off the wall. And we'll figure out how to refit the other ones. All right, we'll see you back then. All right, we just took it off the wall. A little bracket that holds air intake there, exhaust there, gas, and pipes down below. All right, we got it mounted to the wall. It's pretty straight, pretty easy. Pipes underneath. What we're gonna do now is take those intake and exhaust and adapt them from, it's like a 4-inch to a 3-inch, and then the 3-inch goes in the inside of that where the seals are. Take the O-rings, tie them up, and then we'll go from there. All right, we have connected up the air intake and the exhaust. This one is the intake. Converted it from a larger pipe down to a 3-inch, which is 3.5 outer diameter. And then the exhaust goes this way. And a little bit of wrangling, but we got it connected. So now we're gonna work on the bottom connections. Okay, we have air lines connected. We have domestic cold and hot water, so in and out. It's not connected, it's just dry fitted. And the thing that we're working on is trying to get the boiler, which we just took that connection, split it off. Okay. And that's going in for boiler out. And this is the second connection. Goes over, we're terminated here for now, and we're going to take them down here and then figure out how to couple them to the boiler connections there. So that's what we're going to be doing next. We also have to get the pipe for the gas threaded and connected up to there, and the pipe is over there somewhere. So we're going to be doing that next. All right, we have hopefully everything wired up here. We got the intake and the exhaust. Down here we have an amazing set of pipes that go in and out, in and out. 2 are for the domestic hot water, 2 are for the heater. 1 is for the feeder, so this is for the feeder. It goes up there. That's for the furnace, and a whole bunch of pipes here. So we haven't tested any of this out, but we're going to test it out now. Put an expansion tank on the heater end, and we have another expansion tank for the hot water, domestic hot water, and we got a whole bunch of valves here. So we're going to turn this on, and we'll let you know how it goes. Okay, we have turned on all the valves. We have one little leak here out of the feeder valve. I'm not sure what to do with that yet, but it's easy to fix if that's the only leak. Now we're turning on the equipment here. It says fill. Not sure what that means. We'll have to figure this out. Wow, that's clogged. All right, we have a few things going on. So we took off the front cover. We have turned the system on. I probably should have filmed the turn on. We had to rearrange the feeder tube, which is that one with the blue handle right there. And the reason we had to take that apart was that it kept on getting some strain, dirt up in the strainer. So it kept on blocking the strainer, which is, let's see if I can point to the strainer's up in there, inside, which is in there. So we had to disconnect the line and refit the strainer and clean it out. I ordered an inline strainer for right. I'm going to put it right before that. But right now it seems clean enough. It's starting to fill the system. The heating portion of it, the heat, not the domestic water. The domestic water we flipped on, and now it's feeding from that feeder line. So we're letting it do its cycle. It's been doing it about 10 minutes now, and we'll come back to it. It's trying to get to 12 psi. So we will see if there's anything else that we need to do. I'll be back. Okay, we have progress. Just like that, the filling is done. Probably took 10 minutes easily. And we got heat going on it. So it's at 120. I have an electric water here feeding this one, so I'm going to shut the electric one off and see if we can start to get some domestic water heat going on here. So we'll come back to it, but it looks like it could be working here. This is great. Okay, we have some progress. It's taken a little while. We have the hot water now heating, and the heater was throwing a heavy limit switch or high limit switch. Still not sure why it was throwing it, but it might have to do with the recirculator. So we went in there, tightened all the wires. It seems like that may have done the trick. Maybe there's a loose connection. The heating recirculator is off at the moment. The hot water circulator is on, domestic hot water. Trying to get to 125 for domestic hot water input. That's what we're measuring there. And then let's see if I can do this without the light. We wanted to get back and measure the hot water output. That's now at 128 pretty consistently. Hot water input, still older one, so that's cold. And that's 114. And we have a circulator in the middle to try to heat up the entire circulation and keep that warm. we're going to wait a minute or two and probably lower the temperature to 120. Let's do that now so that we can understand, so we can understand if it hits the limit. So maybe we'll do that later. Okay, we'll be back. We just turned off the recirculator. Let's see what happens here. I don't think anybody's using the hot water. The heating pilot light went out. It's right up here. So now we're just recirculating, probably to run through a timeout. Figure out if that is what we need. Alright, we get it all back together. It's firing up now. Let's see what it does. I think it's going to 180. Let's see what it does on the back. Alright, we have the heat went on. It was at 180. I turned it down to 100. Summertime or springtime, we don't need it on. I also turned on the heat circulator, which is external, just to equalize the temperature on the pipes. That seems to be working. I think I'm going to need to have to wire this to the air handler at some point. No failures yet. So whatever we did, we replaced the circulator, which is on the lower right there, and then we replaced the computer board, both of which Rheem sent. We'd also replaced the three-way valve, and no errors right now. We haven't tested the hot water temperature, but let's just let it do its cycle on the heat, and then come to rest, and we'll see what's happening here. Okay. All right. So you hold this button down for 5 seconds. It shows up with these codes. These codes mean something. We're going to go into DTP, which is chronology gather temperature. This is heating supply temperature. Let's see what it is. That's 100 because that's what I have it set at. That's what it's circulating at, so that's come out of that. Heating return temperature, also at 100, so that means the temperature is holding at 100, but that's what I have it set at. Now let's go to the D-hot. Hot water is at 65, and I don't have that circulating. I'm going to turn that on in a second. And then cold water is at 64. It's also not circulating. So I'm going to turn that on in a second. So that means domestic hot water and domestic inlet and an outlet is at 64. So there's no call for it in the house right now. So I'm going to go turn that on and come back. Alright, so I turned on the hot water circulator. And that is quickly kicking up the temperature. You can see it moving up. You can see the flame on right there. It's moving fast. Very impressive. Let's see what happens here. Seems like it's going quite well. The domestic hot water standard set to 120, so that should hit 120. And then pull itself back. It did. We're at 120. 122, the gas went off. So that circulator's on. So now 114. Let's come back down. Let's see what happens there. Right now I just have it circulating through a short loop in the domestic hot water pipe. At 115, heat hasn't turned on yet. Might just stay there for the delta temperature. So the next test is I'll turn on the sink upstairs. Okay, we'll be back. Alright, so I turned on the hot water circulator, and that is quickly kicking up the temperature. You can see it moving up. You can see the flame on right there. It's moving up fast. And it goes let's see what happens here. Looks like it's going quite well. The domestic hot water standard set to 120, so that should hit 120 and then pull itself back. It did. We're at 120. 122, the gas went off. Looks like the circulator's on. So now 114. It's coming back down. Right now I just have it circulating through a short loop in the domestic hot water pipe. Starting at 115, it hasn't turned on yet. Might just stay there for the delta temperature. So the next test is I'll turn on the sink upstairs. Okay, we'll be back. Okay, so we have turned it up to 130, and that is quickly hitting 130, extremely quickly. It's got a nice circulation going, and we've got the water upstairs on, and you can see if it hits 130, and then it should back off that flame. That's the flame there. Turns off, that means it's cleaned up. See if that happens. So 134 now. Should shut off, I would imagine. Return and supply. Probably 130. Using my backs off at 4, 3. It seems to be holding it. Since the test this up, or since the circulator is on, which is represented with that little handle on there, it may stay on for longer. So I'm going to go up and check the sink, and I'll be right back. Okay, I think we are in a position to call this done. We've got everything back on, the cover back on. Temperatures seem to be working fine. We haven't fully tested the heating portion of it, just because it's spring here. But everything seems to be working. The final design under here for the ins and the outs. And then just one thing to note when you're hooking up the heating return and the heating supply, which is here, and then the heating output, which is here. You do put a little loop back in there so that if there's no heat being called from no external source, it does loop back. And there's a design in the user manual for that. So here it is. We'll see if it works and continues to work, and I'll report if it doesn't.